Test. Okay, so with my can put it on the table there. I have my other mic here so that I can record myself. Alicia is not going to be in school for a while because she's traveling to India for some personal family matters. So I'm going to record our class so that she can hear us. Now, so Zhexin says here, decimals as they look today were used by John Napier, a Scottish mathematician who developed the use of algorithms for carrying out calculators. The modern decimal point became the standard in England 1619. Well, but is that true that there's the earliest time of decimals? And then he goes on to, hey guys, are you looking at this? I already posted. How come nobody's responding? Let me post it again. That's the John Napier, that's the person. Okay, then he talked about the person who created maths. He didn't really quite find the person, but the evidence of mathematics dates back to the ancient Sumerians, the earliest civilization in Mesopotamia. You will learn about this in social studies when you reach primary 5. That's really cool. So I'm excited to see what Zhexin has found here. Okay, and also our friends on Class Dojo. Let me check where's Class Dojo. Is it here? On Class Dojo, some of our friends. Where? Or slide more. The ideas. Slide down. Oh, this one. Okay. Okay. Anyway, so I want to go to the Class Dojo. So if you check out our portfolios here, new share, and I go to here, I've got a message from Lisha's mommy, and there's Ayla here with her pose of the decimal cup. Okay, that's here. And I also have, okay. And then I also have Lisha's mommy message this to, to me. Yeah. Yeah. Okay, so I would like to give them their prizes for participating, because I was hoping for more students to post though. But never mind, let me give them their prizes first. So, Lisha and Ayla and Zhexin, you can pick one of these. Come. Zhexin. No, they're pen.
All of them are.
Yeah, all of them are pen. One is a multicolor pen and one is a Avenger pen. Okay. All right, so thank you for participating. Meanwhile, just for fun, for interest, let's take a look at this.
Human beings, from our earliest beginnings, have searched for solutions to basic problems, building homes, measuring space, keeping track of seasons, and counting objects. Human beings, from our earliest beginnings, have searched for solutions to basic problems, building homes, measuring space, keeping track of seasons, and counting objects. Over 30,000 years ago, early Paleolithic people kept track of the passing seasons and the changes of weather for planting. To represent the passing of time, they carved tally marks on cave walls or slashed tallies on bones, wood, or stone. Each tally stood for 1. But this system was awkward when it came to large amounts, so symbols were eventually created that stood for groups of objects. Sumerian clay stones have been found that date to the 4th millennium BC.
So what does he say?
A small clay cone was used for 1, a clay ball was used for 10, and a large cone stood for 60. Written records from around 3300 BC show that Babylonians inscribed amounts on clay tablets with a reed. They used a nail shape for 1s and a V on its side for 10s, combining these symbols to write other numbers. For example, Babylonians wrote the number 19 as. The ancient Egyptians used objects from their everyday life as symbols. A rod stood for 1, a cattle hobble was 10, a coiled rope was 100, a lotus flower was 1,000, and so on. The number 19 was a cattle hobble and 9 rods. The early Romans created a number system that we still see today. Along with other symbols, they used an X for 10 and an I for 1. By the Middle Ages, Romans were putting the I to the right of the X for 11 and to the left for 9. So they wrote 19 as XIX. All these creative number systems show groups of objects as well as individual objects. Some of the oldest human counting systems rely on fingers and toes, so they were based on 1s, 5s, 10s, and 20s. The Zulu word for 6 means to take the thumb of the right hand, meaning that all the fingers on the left hand had been added up and the other thumb was needed. Other systems evolved from commerce. The Yoruba in Nigeria used cowrie shells as currency and developed an amazingly complex number system. It was based on 20s and on the operations of multiplication, subtraction, and addition. For example, they thought of 45 as 3 times 20 minus 10 minus 5. Knots tied in cords and strings were used for recording amounts by many cultures, like the Persians. The Incans used a more refined version called a quipu, a thick cord held horizontally from which hung knotted string. The kind of knot the Incans used, along with the length and color of the cord, represented 1s, 10s, and hundreds. In today's world, almost every industrial culture, and it took another 800 years for the idea of 0 with place value to be constructed. This big idea dramatically changed the face of mathematics. We humans have always shared with one another. When early cultures shared their food and water or wanted to divide their land in ways that were fair and equal, fractions gradually emerged as symbols for these fair share situations. The ancient Egyptians used unit fractions. Fractions where the numerator is 1, like 1/2, 1/3, and 1/5, and would add and halve these fractions. If they wanted to divide 3 loaves of bread equally among 5 family members, they'd first divide the first and second loaves into thirds. Then they'd divide the third loaf into fifths. Finally, they'd take the remaining 1/3 from the second loaf and divide that into 5 pieces. They wrote this as 1/3, 1/5, 1/15. Today, we would represent this sharing with the fraction 3/5. 3/5 of a loaf for each person, or 3 loaves divided by 5 people.
And then
the Sumerians and early
fractions,
Babylonians invented a number system.
You get to hear a lot more about the number system, okay, and how they do calculations. And that's what you will be learning at primary 5, okay? And this one you already know. So I'm going to skip a bit of this, but it will tell us a little bit interesting ideas of how people coming from counting one by one to developing different ways of counting and the decimal system. Now, we're going to skip this video and go on to another one that describes the decimal system a bit more, and we probably will need to remember the things that's in there. So we've got decimal system of India. I'm going to skip this video. If you like, you can go back and check it out. It's called decimal system of India. They'll tell you a little bit more of how the Hindu Arabic people who came up with the numeral system using the digit 0 to 9 to represent all the numbers and all quantities in the world, and how the decimal point come about. Now we're going to skip that video and come straight to this. And there are some of these parts of this video that you might have to remember for the purpose of your doing the work later. I must remind you that I'm recording a video, so what your actions are is going on the video. Okay, let's take a look.
Hi, I'm Rob. Welcome to Math Antics. In this video, we're going to learn about decimal place value. As that name suggests, it's related to regular place value, so be sure to watch our video about that if you haven't already. In that previous video, we learned how to count using just 10 different digits and number places that represent different size groups. For example, if we needed to count 235 apples, we use different number places for counting by ones, by groups of 10, and by groups of 100. The digit 2 in the hundreds place represents 2 hundredths. The 3 in the tens place represents 3 tens, or 30. And the 5 in the ones place represents 5 ones, or just 5. It's a pretty amazing system if you think about it. It only has 10 digits, but those digits can be reused in different combinations to count any number from 0 all the way to trillions of apples and beyond.
If you have trouble paying attention, I suggest you put the cups away. Because if your eyes are not looking at the screen and your hands are moving the cups, clearly you're not able to listen. So you need to be listening. I will repeat myself. You need to listen to him, watch what he's doing, take a look at his examples, and think of how you can use whatever he's saying in your work later.
But as amazing as it is, there's just one little problem with our number system so far. What if you don't have a whole apple? In the place value video, we only learned how to count whole amounts, or what we call whole numbers, which is the set of numbers you get if you start with 0 and then count by ones, 1, 2, 3, 4, and so on. But there are things besides whole amounts. It's possible to have just part of something, like just part of an apple. And that means there are in-between amounts. You might have 1 apple or 2 apples, but you could also have something in between that, like 1.5 apples. How can the base 10 number system handle situations like that? The answer is decimal places. Decimal places are a way of extending the base 10 number system so that it can represent amounts that are in between whole amounts. Decimal places are just like regular number places, except that instead of using them to count groups, we use them to count parts or fractions of things. To see how the base 10 system is extended with decimal places, let's look at the pattern of number places that we saw in the last video. We started out with a number place for counting things one at a time. And when we hit the limit of counting with it, we used another number place on the left side of it for counting groups of 10. By combining those two number places, we could count from 0 all the way up to 99. But when we needed to count beyond that, we used another number place on the left side of it for counting groups of 100. And when those places were maxed out, we added a place for counting by groups of 1,000, and then by groups of 10,000, and so on. See the pattern? Each time we added a new number place, it was located to the left of the previous one. And each time, it represented groups that were 10 times larger than the previous group. Since the amounts that our number places represent get bigger and bigger as we go to the left, it makes sense that number places for counting smaller amounts, like parts of something that are less than 1, will need to go on the right side of the ones place. That's where the decimal places are found. And just like the whole number places can go on forever to the left, counting bigger and bigger groups, the decimal number places can go on forever to the right, counting smaller and smaller parts or fractions. But if number places go on forever in either direction, then how do we know which place is which? I mean, if they all look the same, or worse, if they're invisible, then how do we know which digit goes in which place? That's an excellent question. We do have a problem now that number places can extend in both directions. Before, when we had only whole number places that extended in just one direction, to the left, we knew that the place that was furthest to the right was always the ones place. But now we know that number places can extend in both directions, so we need a new way to tell which place is which. What we need is a point of reference, a place that we always start from. And for that, we use a special symbol called the decimal point, which in the United States looks just like a period. Basically, the decimal point acts as a separator. It separates the number places that are used for counting whole values, which are on the left side of the decimal point, from the number places that are used to count fractional values, which are on the right side of the decimal point. And that's why you don't see a decimal point in every number. If there's no decimal digits in a number, like in the whole number 25, then you don't need to show the decimal point. It's safe to assume that the digit farthest to the right is in the ones place. Of course, you could still show the decimal point if you wanted to, since it's always immediately to the right of the ones place, But if there's no decimal digits, then we don't need to separate them from the whole number digits. If a number does have decimal digits, then we call it a decimal number. And the decimal point helps us quickly recognize which digit is in the ones place. For example, if you see a sequence of digits like this, 1, 2, 6, 0.53, you can tell right away that the digit 6 is in the ones place because it's immediately to the left of the decimal point. That means this 2 is in the tens place, and this 1 is in the hundreds place. Okay, but what about the digits that are to the right of the decimal point? We know that they must be in decimal number places, but what are the names of those decimal number places, and what values do they count? Well, looking back at our number place pattern, we see that each time we move to the left, the new number place counts amounts that are 10 times bigger than the previous place. So, each time we move to the right, that place should count amounts that are 10 times smaller than the previous place. Since the ones place counts by ones, the number place to the right of it should count by amounts that are 10 times smaller than 1. The amount that's 10 times smaller than 1 is called a tenth. It's the amount you get if you take one whole, like one whole apple, and divide it into 10 equal parts, keeping just one of them. 1/10 is what we call a fraction, and fractions are written using a special notation that has two numbers with a line between them. The number on the bottom tells how many equal parts a whole amount is divided into, and the top number tells you how many of those parts you have. So the fraction 1/10 is written like this, 1/10. Getting back to our apple counting example, previously we could only count whole apples. But now that we have a number place for counting tenths, we can count tenths of apples too. We can use the ones place and the tenths place together to count amounts that are in between a whole number of apples. To see how it works, let's start our counting with one whole apple and no tenths. That means that there will be a 1 in the ones place and a 0 in the tenths place. But now, let's start adding tenths to that. For each tenth that we count, we increase the digit in the tenths place by 1. 1/10, 2/10, 3/10, 4, 5. Let's pause for a second to notice something important. Do you see that having 5/10 of an apple is the same as having 1/2 of an apple? That's because 5 is exactly half of 10, and the fraction 5/10 can be simplified to 1/2. That's why having 1.5 apples is the same as having 1.5 apples. Pretty cool, huh? Anyway, back to counting. 6/10, 7, 8, and 9/10. Now we have one whole apple and also 9/10 of an apple. But our tenths place is maxed out with the digit 9. That's as high as it can count. So what do you think will happen if we add one more tenth? Yep, those 10 tenths combine to form one whole apple, and that will cause our ones place digit to increase to a 2. We now have 2 whole apples. Even though one is made up from slices, the amount is still equal to one whole. See how decimal digits help us count in between whole amounts? But wait, there's more. More decimal number places, that is. The tenths place allows us to count in between the ones. But what if we want to count amounts that are in between the tenths? The decimal number places keep on going to the right, and each time they count amounts that are 10 times smaller than the previous amount. So, if the tenths place counts fractions that are a tenth of 1, then the next number place over will count amounts that are 1/10 of a tenth. 1/10 of a tenth is called 1/100th, and it's the fraction you get if you take a tenth and then divide it into 10 equal parts. It's a very small fraction, and it's called a hundredth because it's the same fraction you'd get if you take a whole and divide it up into 100 parts. So its fraction form looks like this, 1/100. Just like tenths could be used to represent amounts that are in between the ones, hundredths can be used to represent amounts that are in between tenths. And just like if you combine 10 tenths, they equal 1. If you combine 10 hundredths, they equal a tenth. And the decimal number places keep on going like that. The next number place over represents fractions that are 1/10 of 100th. That very small fraction is called 1,000th because it would take 1,000 of them to make one whole. And the next place over is 10 times smaller than that. It's called the 10,000th place. And then there's the 100,000th place. There's the millionths place, and so on. So do you see how truly amazing our number system is? It can represent any whole number amount, no matter how big, by adding bigger and bigger number places to the left. But it can also represent amounts in between those whole amounts, with more and more precision down to the tiniest fraction imaginable by adding more and more decimal number places to the right.
That is truly amazing. In fact, it kind of makes my head hurt just thinking about it. Of course, could be this doggone pot I wear in my head all the time.
Okay, so now that you know how decimal places work, let's talk briefly about how we can show their place value and how we can write decimal numbers in expanded form. A digit's value is determined by the place that it's in. So if a 2 is in the tenths place, it stands for 2/10, which can be written with the fraction 2/10. If a 3 is in the tenths place, that stands for 3/10, or 3/10. If a 4 is in the tenths place, that stands for 4/10, or 4/10, and so on. And just like a 2 in the tenths place stands for the place value 2/10, a 2 in the hundredths place stands for the place value 2/100, and a 2 in the thousandths place stands for the place value 2/1000. Knowing that will help us write decimal numbers in expanded form, like the one we saw earlier, 126.53. The expanded form of the whole number part is easy. We learned how to do that in the last video. 126 is 100 plus 20 plus 6. But now we need to add the fractions represented by the decimal digits too. Since there's a 5 in the tenths place, that stands for 5/10. So we need to add the fraction 5/10 to our expanded form. But we also have the digit 3 in the hundredths place, which stands for 3/100. So we also need to add the fraction 3/100 to our expanded form. All right, so that's a basic intro to decimal number places. There's still more to learn about them, and as you can see, decimal number places have a lot to do with fractions, which you may not have learned very much about yet. But that's okay. Once you do learn more about fractions, it will help decimal number places make even more sense. And there's several Mathematics videos about fractions.
Okay, I'm going to stop in here. Now, it is quite a long video, 11-minute one. It summarizes all you need to know about decimals up to the point of thousands. The worksheet on page 22 actually. So the whole video, the 11-minute video, can help you with your work until page 22. So in fact, if you were paying attention and you were able to understand what he was sharing, that would mean that you would have little trouble to finish your work by yourself until page 22. However, if you have trouble listening and you couldn't remember what he said, then you will have some trouble. Then what you need to do is to have your textbook. And the textbook will share from, you can see the cover page, page 1 to page 20 of the textbook. We'll introduce all about fractions, from all about decimals and fractions, from the fraction to the decimal, from 10th place, the first introduction, the decimal points using the number discs, the expansion in place value. So you learned about place value earlier this year. You see the expansion of the numbers, that's what we have been practicing yesterday. And you saw in this year's work just now. And then all the way as you continue, the examples are all here. If you look at your textbook examples, it follows so closely to the ones in your workbook. So if you check out your textbook and use it in reference with your workbook, then you have no issue completing them as well. All the way to the thousands, page 20. So you can see some of these, I use them as examples to you as well. I remember Phaedron with his thermometer picture in class dojo as well. So many of these examples. So you'll see that if you use your textbook to help you with your work, you'll be able to answer them without, with less difficulty. One of the easiest way to get access to knowledge. Then thereafter, look, the 11-minute video isn't all about decimals that you need to know for primary 4. Other than that, you also need to do comparing and ordering. So if I go to the cover page and show you again, these are the, oops, click too fast. These are all the things you need to do. Chapter 7, the whole of chapter 7 and the whole of chapter 8. So just now, if you hear him sharing, the 11-minute video was only page 1 to 20. Beyond that, you need to be able to do comparing ordering, just like you did for whole numbers. Number patterns, rounding and estimation, just like how you did for whole numbers. Converting fractions to decimals, decimals to fractions, as well as the 4 operations of decimals. Addition, subtraction, multiplication, division, and word problems. So it's a very huge chapter. The 11-minute video only up to here. Okay? Now, if that's okay for you, I will give you a bit of a time break. What is the break time? It means that here, we should have completed to page number 6. I will give you 10 minutes to continue to page 11 by yourself now. All right. Your job is to explain to us later the answers to, oh yes, you need the book. You can use mine first. I'll get you a book. You can use mine first until page 6. You can try on 6 to 11. Okay? All right. Later you're going to be explaining how to do, okay? I didn't really want to try explaining as well. Is that here? Okay. Yep. So all of us are going to work on to page 11, and our friends are going to explain. Okay. Can you write neatly, please, Dashin? I cannot tell what you're writing here. This is not neat. I don't know what this. I cannot figure out your handwriting. Are you working on it? Go until page 11. Why is your page 2 still empty? Right, so you want to do the explaining? Yes, sir? No? All right. Come. No, it's until page 11. You're on 21. That's not correct. No, get to your table. Get over there. Come here. Come explain to your friends how you do it.
I don't know how to do it. I just anyhow do it.
Huh? Do you think anyhow is an acceptable way of explaining? No, you got to explain. Remember how you explained this to me yesterday? Come, sit down. Okay, and then, so we got our friends to help us. Over here, Horan's is page 4. Those of you who have not done page 4 yet, you can look at him. Come here, the microphone with you. What's the microphone? Yeah. It does work. Okay. Now, I'm going to stand further away and make myself there so you can hear Horan explaining. I hope you're not just copying answers. Some of you, I see your fingers moving quickly.
Yeah, you guys keep
Now, remember, no. If you think about coffee. Is it another thing that hi?
I don't think you know. So what? 10 cents is one. Very easy. And then the rest of it. Because this microphone. Bruh. So 1 cent is 0.1. So 10 cents is 1. Then 15 cents is 1.5. And then 1 cent is 10. I think you know. And it's 1.
He's coming out. How do you get 1.6 again? Well, so if I was to demonstrate on the board, or actually I can subtract it. Okay, okay. This is the probably a difficult to say that. Yeah, I think you know. So one head, 6 watts and 8 10. Although the last part that I take for the first problem. Remember what we said? First find the decimal point with the person in the video, the next active videos, he also mentioned, right? Right? So if you notice that what he said earlier on with the number expansion, one 10, 6, 1, and 8 tenths. Find the ones, go with the decimal point. So you have your ones. If you don't want to spell it out, you can go with the O, T, H. Then you have the small letter T, small letter H, small letter TH, or the decimal point. Do you know what I'm talking about? You have the plastic sheet, right? Mine's at the table. Do you have the plastic sheet with you? Show me. Yeah, thank you. So if you look at it over here, follow the help that I can show you here. Thousands, hundreds, tens, and ones. How can you show it on the screen as well? The plastic sheet is there. Yes. Yeah. So you can write down, show the place value chart, please. Please show the place value chart. And I can fill it in 8 tenths. Find the decimal point after ones, put it in 8, 6 ones, 1 10. So you've got 16.8. Is that all right? Can you try to write neatly? Some of you, your handwriting are beyond readable. Can you show the place value chart, please? The chart. Yeah, move it down a bit. Yes. No, up a bit. Sure, it's got to be helpful than that. Yeah, okay, then. Yes. So you see, like, if I'm going to do it in a staggered manner, like the Licious cup, how she did it, she had the decimal points placed together, and then she put down there 8 tenths, 6 ones, 1/10. And you add them up to 16.8. Is that right? Okay? Now, that's okay. We move on. Is this page all right? Any difficulty? Sorry? You want to try out? Sorry? You have a question? Now let's look at page 7, everyone. There's a question on page 7. How do you go page 7? Page 7. Now let's show us the first question. Now, can you explain? Can you read through the question and annotate the question, please?
So this is 0. That means it's nothing. And then this is 1.
Read the question, right?
Right. The decimal represented by the letter.
What's the meaning of represented?
That means what? What is the how many is the letter?
Yeah, what is the letter pointing at? At which part of the number line?
And here,
Read the next sentence.
express its decimals as a fraction.
What's the meaning of the word express?
That means you convert it or expand it.
You convert it or you show the decimal as a fraction. Right, okay. A, can you explain how you got 0.9 and then 9/10?
So this is 0 and then this is 1.
Okay.
So 0 into 1, there is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. There is 10 small things. And then
10 small units. The counter spaces, never the lines, remember? 10 spaces. So,
so this is 1, 2, 3, 4, 5. So this is 5, 0 to 1, 0.5. So 0.1, 0.2, 0.3, 0.4. So continue. And then so this is 0.6, 0.7, 0.8, and this is 0.9. So that's how you get 0.9. And then 0.9 is 9 out of 10. Just
okay. Now, an easy way to remember this is that counter spaces, the fraction that we learned before, between 0 to 1, you chopped up the apple to 10 parts. Can you please don't cover what you wrote? You cut between 0 to 1, between 1 to 2, you chop the whole apple into 10 parts, right? So the denominator of the fraction is 10. Can you understand that? Now, so you have ones, the first decimals, tens. So I cut the one whole apple into tens. So that's why you got the fraction, denominator 10. That means you open up the first place, decimal place toward the right side as 0.9. Now, how do you get the second one? Haran, don't need to erase this, correct?
the second one is B, so it's 1 to 2. It's same as the 0 to 1. So this is 1.1, 1.2, 1.3, 1.4.
Could you move it a bit to show the number line? Yes. So between 1 and 2, so it's 1 whole apple and a bit more. Can you understand that? You got 1 whole apple and a bit more. What is the bit more?
0.5.
0.5?
Yeah.
0.8.
Yeah.
Correct? Yeah, 1.5 is what he's writing down at the in between of 1 and 2. So between 1 whole apple and 2 whole apple, you can have 1 and 1.5 apples. So what is 1.5 apples? It's actually 1 and a half apple. Can you write 1 and a half there? Can you tell me? Let's do a quick recall. What do you call 1 and a half? What kind of fraction is this? 1/2 is is it an improper fraction?
No.
What is this?
It's a proper fraction.
Is it a proper fraction? It's a mixed number. Thank you, Zahir. Can you remember what mixed number is?
Yes.
A mixed number is made up of a
whole number and
one. That's very good. A whole number part and a fraction part. So same thing as with decimals. Now you don't call it fraction. You call the fraction as a decimal part, which is the same. Yes, Sachin. Now, if you write it as improper fraction, it's acceptable also. But what is the improper fraction? All right, can you write it down as a side as well? Sachin says he wants to express this mixed number 1 and 8/10. That's how you read the mixed number. 1 and 8/10 as an improper fraction. What would that be?
Oh, so 1 is an improper fraction equals 10 plus 8 equals 10.
That's very good. And class, all of us need to know how to do this. Okay? Not just Katrina, not just Stefan who is saying that I can write down 18/10. Okay? All of us has to be able to do it. So if you feel like, oh no, I didn't like fraction, the chapter on fractions. I'm so glad that fractions is over. Hello, sorry, fraction is here again. Fraction is really a very, very important chapter. So you want to gain confidence, you want to be able to do decimals well, you need to gain confidence in fractions. So if you need to, always go back to revised fractions unit. Okay? Now, next one. Moving on, the bottom. C and D. Zahir, you want to try to explain C and D? No? Okay, then how you continue? What page is this again?
This is page 7.
Page 7. Can you look at the C and D? Okay. How do you get the C as 8.4?
So between 8 and 9 is 8.5. The unit before 8.5 is 8.4. I think that's not difficult. And then you need to express it in fractions. Then that is 8/4. That's also very easy.
8 and 4/10.
Yeah, and then this is 9 and 10. Between 9 and 10 is 9.5. And then 2 units before is 9.3. And then express it in fraction is 9/3.
Now, Horan, I'm glad you find that it's easy. But I would like to tell you that not everyone may find it easy too. And I would like to tell everyone, if you find that it's hard, it's a good thing.
Why?
It shows that your brain is growing. Really. Your brain will grow and you become wiser if you find things are hard. If everything is easy, then you are not going to get smarter. Okay? But at the same time, Mr. Chen, you're going to be more encouraging than saying everything is easy. Okay? Because if I find this difficult, I won't feel encouraged if you say it's easy. Right? Correct now, everyone? Yes, Nigel? Now, so to make it more challenging, I'll ask Horan, can you express 8 and 4/10 as in its simplest form?
Huh? Oh, 8 and 4/10. So it is equal to 8.
Really? Two-fifths, very good. Oh, Mr. Chen, someone's faster than you. We've got Rachel and Kayla who say 2/5 earlier than you. Okay, sure. So class, we need to be able to do this as well, okay, in time to come. Let's move on, next page. 8.
The last page.
Was it okay? Some of you already accomplished it. Now on 8, you need to be able to mark out on page 8. Are you on page 8? You look like you're on a different page. Yes, you're on the correct page. Okay. You need to mark out correctly where they are on the number graph. First, that's why, remember, I did a polar bar. I keep emphasizing on number line because it does come back to us. Why is it so important? Because it tells us the position of where these numbers are between holes. Now, as I was talking just now, Haoran wrote down some other numbers between the number line. I think he's trying to help us here. Can you explain why you wrote new things on the number line?
Because between the 5 and 6, 5.5, and that's the easiest way to find 5.2 and 5.9.
Oh, okay.
5.2 is like 3 units before 5.5, and then 5.9 is 4 units after. That's like,
Okay, but how do you know and how can you be sure that right between 5, this from here, sorry, to here is 5.5 and not 5.5 something else, 5.50? Could this be 5.02? Can this be 5.02?
no, because the question says 5.2.
Because the question says 5.2, but it's given a question. But what's in the number line tells you that it must be 5.2 and not 5.02? Yes, not here. Very good. That's the most important information. So he says here, class, from between 5 to 6, he's very sure that this is 5.2 and Howard's clue, right in the middle of 5, right in between 5 and 6 is 5.5. And that wouldn't go wrong because it's right in between 5.5 to 6. And here says, keep in mind, always check the spaces. Check the spaces, 10 spaces, so it's the first decimal place. So 4.2. Is that all right? Can you understand? Can I? Okay. Now, if I want to challenge you, because Haran said easy, everything easy, easy. Can you mark out where is 5.23?
Oh, 5.23. Wait.
I need to see the hand only.
Huh? I still do it.
Oh. Is it there?
Not there. It's somewhere here.
I only see your hand. Now it's done. Okay. So, okay, so he shows us some. Earthquake. Hello. Okay. He says somewhere. Earthquake. Somewhere here. Why is it not on the line?
Because on the line is 5.2 and 5.3, so cannot be 5.23.
Then what is 2, 3? What place is the digit 3 in?
100.
Hundredths place. Very good. Okay, I heard what you said. That was good also. Okay, move on. Oh, it's supposed to have meal break as well, right? Now, at the same time, you're on 8. Have you completed 8? Page 8? Okay, who needs help on page 8?
I hope no one.
Okay. Then we have to try out a little bit. Idea, do you want to take on the mic to try?
Huh? Oh.
You can take turns, you know.
Okay.
Who wants to try out explaining?
Yay.
Okay. If nobody's stands, no one standing up, then that's how you have to continue. Zahir, are you going? Are you going to try explaining?
Why?
No, okay, then Haran, sit down.
No.
I didn't go. Justin, can you help? You can have your snack while you are trying it out, okay? Then we'll move off to hundreds as well right after this. Okay. I did. Our friends did have on page 8. Can you go through page 8 as well?
We need a microphone.
Yep. You didn't mark out the. You're supposed to. I did. Can you show us the question on page 8 again?
That's the last page.
You gotta hold the microphone as well, the one that's on the clip. Yeah, this goes to recording. Yeah. Can you show us page 8? Show us the question again, please. Some of our friends forgot something important and they are doing their work. Show us the question right on top. Question 2. Everyone, here says read.
Draw an arrow to mark the position of each decimal on the number line. Express each decimal as a fraction.
Annotate the question now, please. Okay, draw a star on the key things that you must do. Draw an arrow. Have you marked out? Can you start on draw an arrow? So you got to draw an arrow to mark the position. The other arrow, the other star is fraction. So the first star goes with, you got to mark the position. So a lot of you didn't notice the first part is just going to give the fraction. You didn't mark up the decimal on the number line. You got to be moving your hand to do as well. Don't use both hands to eat, please. Okay, go on explaining. Yeah. How do you get, let's say, explain 7.4.
7.4 plus this is 7 and 8. This is 7.5. This is 1, 2, 3, 4. Continue.
How do you get the decimal place, the fraction?
7.4, 7 is a whole number, and 4 is 4 because everything possible.
Can we all understand that? Is this cool? Is this difficult? Okay? Okay. Hold on. Let's focus on the task at hand first. Okay, if you're okay, shall we move on?
Yes.
Move on to hundreds now. I think you want to follow on to hundreds. Okay. Go through the first page first, okay? Then you take over for the next page. Page, what page is the hundreds on?
Page 9.
Page 9. Okay. Okay, page 9. Are we okay, everybody? No, never mind. Don't need to tear out yet. I will collect your work tomorrow so that I can mark over the weekend.
I didn't wrong. You did it wrong. This is 1, 2, 3.
It's okay. It's okay. I think can you erase it nicely and write nicely? Now, can you explain your mistake? Yeah, and that is actually a very common mistake. Now, can you tell me why is it 300?
0 is 100. 0 is 3.
So the whole thing is 100.
The whole thing is parts.
Oh, so there's 100 parts. So this whole square is actually made out of 100 parts. It's not 100 individual wholes, but 100 parts of one whole square. Can you understand that? I'm fond of this neck break. Some of you eat and drink, and your brain is not stop working. All right. Singer, can you repeat what I just said in your own words? Do you know or don't know? Salini, do you hear what I said earlier? Yes, I want to say something. Thank you. Horan says, you eat and drink and you cannot hear anything else other than what I said. And that proves it. Horan isn't eating, he heard what I said. Lisha was not, were you eating? Do you hear what I said just now? Tell me about it. I'm talking about the decimal. Do you hear about the decimal? No. So that just proves it. Do you think you need to hear me saying, I'm not too fond of the meal break? Do you think you need to hear me talking about the decimal? Well, those are important. I clearly say that I don't like, not too fond of the snack break. But what is even more important is you got to hear about the decimal. Owen, you tell me describe this figure to me, to us. Describe this figure to us. What can you see in 1A, this figure? What is this shape? It's a square. Now, in this square, is it one whole square or 100 squares? You got one whole square. What is happening to this one whole square? Say that again. What do you say? You said something that was good. No? So, Owen says, this one whole square is being chopped up into how many parts? 100 parts. And then you shape 3 out of the 100 parts. Now, imagine you take the bread that Adrian was eating. One piece. One piece. Mommy gave her one piece of bread. If you imagine you chop her bread into 100 pieces, what do you think the size of that bread will become? Maybe so tiny that is to use to feed the birds, maybe. And ants, maybe, right? The same idea here. Imagine this is Aiden, he's also eating bread here. Some breads here. And then there are some pieces. Can you see? Yeah. Can you imagine you take one of these pieces and chop it into 100 pieces? Okay, or maybe I should bring bread and ask you to chop into 100 pieces. Huh? And then you got to eat that one piece by one piece. Yeah, give me bread. Okay. Right. So that's how you got a fraction. And you notice that when you chop up the 100 pieces, it actually opens up the next decimal place. One decimal place, two decimal places. The second decimal places is hundredths. Everybody say hundredths. Hundredths. How many hundreds are there? 300ths here. Now, question, extension. ID, can you tell us? 100, I said the bread, right? The bread chopped into 100 pieces. If I compare this, when I chop up the one piece of bread into 10 pieces, which one is smaller? The 100th pieces. By how much? 10 times smaller. Not just 10, huh? 10 is plus 10, huh? Minus 10. Is it divided by 10? Thank you, Edmund. I like what you are listening, how you are responding. Maybe Edmund, you can also be there, huh? Okay, coach Coach Hauran, Coach Aidin, and Coach Edmund. Huh? Okay, moving on. Now, look, we are in the hundredths place now. But shows us 0.25. Why is it the number 2 is not at the second place, the second decimal place?
Because the number is the tens. 25, 25, 100. People find the favorite. 2, and 2, 10, 20, 500.
So if I write this in words, can you write down ID? Here, 25 hundredths. Spell, let's see if you can spell. Don't spell 25, spell, just write 25. Write down 25 as a numerals. Write down 25 as numerals. So I've got 25 hundredths. If I express it in tens and hundreds, what should I be writing? Rashan, can you answer this? What is 25 hundredths in tens and hundreds? So I've got 25 out of 100 here. We were trying to explain why 0.25, 2 is in the 10th place, and 5 is in the 100th place. So 25 hundredths is also known as how many tens and how many hundreds?
Hello.
2 tens and 5 hundredths. Who can understand? That's very good. Is it important that everyone can understand? Okay. So, could you continue to page 11? Who has already finished? To page 11? So, minimally, you should go up to page 12 for tomorrow. Is that okay? And then we will try, and my goal is that we can take turns and put everyone there, speaking into the mic to explain to everyone. Okay? Everybody should be able to do that. Okay? You must be confident in yourself. All right? Okay, you can pack up your things and go for mother tongue. I'll see you tomorrow.
Okay, wait. Go for mother tongue.